Imagine orchestrating multi-million-dollar deals in, well, mere seconds with absolutely zero personal risk of debt if it somehow fails.
Mhm.
Think about borrowing potentially unlimited capital with no upfront collateral, executing these incredibly complex financial maneuvers, and then repaying it all perfectly within a single blockchain transaction.
Sounds impossible, doesn't it? Like something out of science fiction.
Exactly.
Yeah.
Or maybe a very, very aggressive day trader's wildest dream. Well, this isn't fiction. This is the, frankly, mind-bending reality of flash loans in decentralized finance, or DeFi.
And it's not just about the borrowing itself, is it? It's really about the underlying tech that makes this possible. The atomic transactions, the intricate smart contract logic, and crucially, the sophisticated automation that powers it all.
Right.
Flash loans are a truly unique innovation. They challenge our traditional understanding of lending, of risk, effectively turning the blockchain into its own sort of programmatic guarantor.
That perfectly sums it up. Today, we're taking a really deep dive into this revolutionary and, yes, let's be honest, often controversial innovation.
Hmm.
We're going far beyond the basics here. We want to explore the intricate mechanics, the advanced tools, the sophisticated strategies involved in flash loans, maximal extractable value MEV as everyone calls it, and the arbitrage bots that really bring these concepts to life.
Our mission today, then, is pretty clear. We want to equip you with an advanced understanding of how flash loans truly work, how they've evolved since they first appeared, the kind of technical stack you'd actually need to deploy them yourself,
Right.
the automation driving these often incredibly profitable opportunities, and critically, the significant risks and the essential safeguards in this incredibly fast-paced corner of DeFi.
Yeah, we'll try and uncover some of the secrets to learning, deploying, monitoring, and potentially, if you're smart and, let's face it, quick enough, even profiting from these unique financial instruments.
Right.
Okay, let's unpack this. Let's start right at the beginning with the atomic foundation of flash loans. This whole concept of uncollateralized lending. It's a unique innovation that emerged directly from the DeFi ecosystem.
It really is.
These instruments have been called, and I love this quote, an outlandish, mind-bending, and unnerving invention. Honestly, I think that's a pretty fair description.
It is, and for good reason. You know, the broader DeFi ecosystem is generally credited for their development. We've seen researchers like Wang et al. Extensively studying their applications and impacts. What makes them so unique isn't just the idea of uncollateralized lending itself, though that's wild enough, is how it leverages the fundamental properties of blockchain smart contracts to create something genuinely unprecedented in financial history.
Right.
The true insight here isn't just zero risk for the borrower. It's that the blockchain itself becomes this kind of programmatic guarantor, a sort of financial safety net that allows for operations previously just impossible in traditional finance.
How does that fundamentally shift things? Because the foundational concept here is atomicity, right? Comes from ancient Greek, means indivisible.
Exactly.
On Ethereum, for example, a transaction isn't just a simple transfer like sending some ETH. It can contain arbitrary nested logic. You could have transactions within transactions, and this chain can go pretty deep. And the critical rule is this. A top-level transaction only succeeds if every single sub-transaction it contains also succeeds. If even one tiny part of that nested logic fails,
Right.
the entire top-level transaction fails.
Right.
It reverts everything, all actions, like they never even happened.
That's the absolute key. This creates what some have brilliantly called the Schrodinger's loan.
Huh, I like that.
It means if you can't repay the flash loan plus the interest by the end of that single atomic transaction, then from the blockchain's perspective, you never even borrowed the funds in the first place.
Wow.
The borrowed funds appear for the duration of the transaction. You use them for whatever complex sequence of operations you've programmed, arbitrage, collateral swaps, whatever, and then they vanish if that repayment condition isn't met at the very end.
So it's literally a zero debt liability loan for the borrower.
Precisely. Which is truly unprecedented. It challenges our very definition of what a loan even is.
That's where it gets really interesting. Initially, flash loans were primarily an Ethereum thing, but they've evolved significantly since then.
Oh, yeah.
We're now seeing developments on Ethereum Layer 2 solutions, chains like Solana. It's expanding access to faster, lower-cost options.
And that evolution is critical. It enables users to tap into new cross-chain DeFi opportunities, supported by, hopefully, stronger safeguards and, naturally, an increased demand for really slick automation.
The shift to Layer 2 and other chains like Solana feels like a natural progression, doesn't it?
It does. Lower transaction costs, faster block times. They mean that the minuscule margins you're often trying to capture with flash loans become much more viable.
Right.
It also opens up a much larger playing field for complex arbitrage strategies that might span multiple blockchain networks, seeking out the widest price discrepancies wherever they might appear instantaneously.
So how do they actually function in practice today? From a technical perspective, you request a flash loan from a provider, let's say a PAVE.
Okay.
Their lending pool transfers the requested amounts to your designated smart contract.
Hmm.
Immediately after that, the pool calls a specific function, usually it's execute operation,
Yeah.
on your contract.
And that execute operation call is the very heart of the whole thing. Your smart contract, now temporarily holding the flash loan amount, could be millions of dollars worth of tokens, that executes whatever arbitrary sequence of operations you've coded into it. This could involve interacting with multiple protocols, DXs, AMMs, all within the tight confines of that single atomic transaction. The speed required means every single line of code has to be optimized for efficiency. Gas costs matter.
And here's the crucial part, the repayment. Once your code finishes its complex dance across DeFi protocols,
Right.
you must approve the pool contract to pull back the flash loaned amount, plus a small fee. And we're talking a really small fee, often around 0.003% of the loan value.
Tiny percentage, but on huge sums.
Exactly. If this repayment, along with that tiny fee, doesn't happen within the same atomic transaction, the entire thing reverts. Poof, like it never happened.
Yeah.
Except for one critical detail.
Ah, yes, the sting in the tail. A critical detail here, often overlooked by newcomers, is that even if your flash loan transaction ultimately fails and reverts,
They'll pay.
you are still charged the gas fees for the computation that occurred. And this is the primary risk to the borrower in a failed flash loan attempt.
And it can be substantial.
Oh, absolutely. The computational complexity of these multi-step operations can lead to significant gas costs. We're potentially talking hundreds or even thousands of dollars for a complex failed transaction. This isn't theoretical. It's a real cost for those who miscalculate or just get outmaneuvered by another bot.
So who are the big players offering these mind-bending financial instruments, and where do they mostly operate? Aavin is obviously a huge one, built on Ethereum, known for offering flash loans, user-friendly interface, lots of assets.
Right, AV is probably the most well-known. Then you have DYDX, which is known more for advanced trading features, but they also provide flash loans for sophisticated strategies.
Uniswap too, right? Even though it's mainly a DX.
Yep, Uniswap allows flash loans directly through its liquidity pools, which makes it incredibly versatile for arbitrage that's tightly coupled with its own AMM mechanisms.
Interesting.
For those looking for multi-chain capabilities, Equalizer Finance is one that stands out. They enable flash loans on Ethereum, Binance Smart Chain, Optimism, Polygon, quite a few. DeFi Saver offers an interesting angle flash loans where the logic is created through templates, so potentially no direct coding for simpler strategies, which is interesting for accessibility, almost like a visual builder for flash loan ops.
Like building blocks.
Kind of. And Balancer also functions as a flash loan provider, lending ETH for prompt repayment. Now, regarding chains. While newer chains show significant activity, Ethereum still absolutely commands the highest value borrowed by an order of magnitude.
Really?
Yeah, the average loan size on Ethereum is often quoted at over $3 million per loan. But their presence is definitely expanding rapidly across Polygon, Arbitrum, BNB Smart Chain, Optimism, Base, and Solana too. The ecosystem is definitely broadening.
Okay, diving deeper into the technical side then, we mentioned the blockchain landscape. Ethereum was first, still commands the highest value borrowed average over $3 million per loan. That's wild.
It is staggering, but while Ethereum holds that top spot for value, flash loans are definitely prevalent across many other EVM-compatible blockchains and Layer 2 solutions now.
Like Polygon, Arbitrum.
Exactly. Polygon, Arbitrum, BNB Smart Chain, Optimism, Base. And Solana has also expanded access, offering alternative environments. The growth of Layer 2s, especially with their lower gas fees and faster transactions, has only made flash loans more attractive for these kinds of sophisticated operations.
The real trend, though, that sounds exciting, is integrating cross-chain flash loans.
Oh yeah, that's the cutting edge.
That opens up entirely new possibilities, right? Composite arbitrage strategies weaving loans across multiple blockchains. Imagine borrowing on BNB chain, doing an ARB on Solana, repaying on Ethereum, all atomic.
It's serious financial acrobatics, as you say. This cross-chain capability is critical for maximizing liquidity and efficiency, pushing DEXs to be even more competitive.
But it adds complexity.
Hugely. It introduces additional layers of complexity in risk assessment, mitigation. You're dealing with different security models, bridging mechanisms. It's not just one set of contract risks anymore, but several interconnected ones.
So if you're going to play in this high-stakes game, real-time vigilance is absolutely paramount. How do you monitor these operations? You mentioned the mempool earlier.
Right. The core of monitoring is scrutinizing the mempool, that temporary holding area for unconfirmed transactions. MEV bots and specialized detection systems, something like FlashGuard, for instance, are constantly monitoring this pool,
Looking for
pending transactions, identifying potential arbitrage opportunities, or even spotting the signatures of malicious attacks before they hit a block.
And you need tools for that. On-chain analytics platforms must be indispensable.
Absolutely. Etherscan is your foundation. As a block explorer, it's cost-effective, gives you foundational data accuracy for tracking transaction details, event logs, basic, but essential.
But for deeper dives,
For more in-depth analysis, Dune Analytics is incredibly powerful, highly customizable for developers, data analysts. You can query historical data, create bespoke dashboards to identify flash loan patterns, profitability trends.
you could build very specific queries, like tracking Evav's flash loan function calls.
Exactly. Trace the funds movements across various ADX, see what paths are profitable. For real-time insights, Nansen really excels. Robust alert systems, timely user updates, invaluable for dynamic market analysis.
And then the institutional-grade stuff. Elliptic, Chainalysis.
Right, those offer tools with high scores in compliance, data accuracy, advanced analytics, often used for serious risk management, detecting illicit activity. Shows you how flash loan monitoring isn't just for arbitrage hunters.
You mentioned FlashGuard earlier using advanced detection algorithms. How does that work?
They use heuristic-based detection. So they monitor for specific function and event signatures, think flash loan, approve, transfer, withdraw within the internal transactions of an atomic bundle.
Okay.
What's really fascinating is their ability sometimes to distinguish malicious transactions before they're even included in a block. They can even initiate these dusting counterattacks via private relays to disrupt attacks.
Dusting counterattacks. Explain that.
It often involves sending a tiny, legitimate transaction, the dust, to a specific address or contract that the attacker's flash loan bundle relies on by altering a crucial state variable or maybe a token balance just before the attacker's bundle executes.
You break their logic.
Exactly. The entire atomic operation of the attacker fails and reverts. It nullifies their exploit and, crucially, wastes their gas. It's a defensive move in the mempool itself.
This really does sound like a high-stakes, high-tech game of cat and mouse. For someone wanting to get into this space, how do you even begin to compete? What's the learning curve like for becoming a flash loan strategist?
Steep. Let's be blunt.
Coding is king, right? You said that earlier.
Absolutely. Successfully implementing flash loans and bots unequivocally requires strong coding skills, specifically Solidity for Ethereum-based chains. This is not a no-coding required field, despite some platforms offering templates like DeFi Saver. Those are for simpler things.
So dedicated self-study is essential.
Immensely. As one Redditor put it quite well, all the information you could ever need is out there. You just need to go out and get it. Knowledge and Solidity definitely helps, though.
What does that involve?
Deep dives into smart contract design, really understanding DeFi market mechanics, AMMs, liquidity pools, impermanent loss, and knowing how to interact with blockchain data sources effectively. You need to think like a smart contract, anticipating every possible state change, every edge case.
Community resources, helpful or dangerous?
Both. Platforms like Reddit, RethDev, Artify can offer discussions, sometimes code snippets. You might find GitHub repos for Node.js and Solidity arbitrage bots. But a serious word of caution about YouTube tutorials.
Yeah.
Many are, frankly, from clowns who don't even know how to make a for loop. They can be misleading, incomplete, or worse, lead to significant financial losses if you copy-paste blindly.
So stick to the source.
Stick to official documentation. It's crucial. Reading Abov's developer docs to understand interfaces like iFlashLoan Simple Receiver is non-negotiable. It prevents common, costly errors and ensures you're using the latest audited specifications.
Okay, so you're ready to roll up your sleeves, get coding. You're an advanced Solidity dev. What's in the essential developer's arsenal, beyond just, say, a text editor?
Right, it's not just any IDE, it's specific configurations and extensions that matter. Visual Studio Code, VS Code, is hugely popular, obviously, but for Solidity development, extensions like Solidity Visual Developer become indispensable.
Why specifically?
They let you trace complex transaction flows visually, help debug potential reentrancy risks within that critical execute operation call. That granular visibility is absolutely critical when pennies per transaction matter.
And version control. Git is standard, but anything special for this?
Git is ubiquitous, yes, but for flash loan strategists, its distributed nature isn't just a convenience, it's a lifeline. Think about rapidly iterating and testing multiple bot strategies at once.
Branching and merging become key.
Paramount. For quickly deploying new logic or rolling back a failed approach without messing up your main bot. You're managing atomic changes in highly sensitive smart contract logic. A single character mistake can cost millions or miss a fleeting opportunity. Fossil SCM is also worth a mention for its self-contained nature, sometimes preferred for smaller, focused projects.
Testing and debugging. How do we push beyond basic unit tests for something this complex?
Debuggers are essential, obviously. But beyond basic unit testing, which for Solidity uses frameworks like Hardat or Foundry, testing positive and negative scenarios, you need robust Hardat local testing environments.
Simulating trades.
Exactly. Simulating trades on a local blockchain fork without risking real assets. This is critical for debugging and optimizing bot performance under realistic but safe conditions. You're not just checking if one function works, but if an entire sequence of inter-protocol calls works under specific, rapidly changing market conditions, all while optimizing for gas.
Reusable libraries must be lifesavers here. Reduces risk, saves time.
Absolutely.
Yeah.
Open Zeppelin contracts is foundational. Secure, community-audited implementations for things like IRC, 20.sol, token interactions. These aren't just snippets. They're robust building blocks you import directly. Saves hours, mitigates common vulnerabilities.
And protocol-specific ones.
Essential. You'll need the specific AV protocol interfaces, like iLendingPool.sol and iFlashLoanSimpleReceiver.sol, to interact precisely with AV's flash loan functions. These define the exact functions and parameters your contract must use.
Managing the process itself, especially if it's a team effort.
Right. Collaboration and project management tools are key for Agile teams. Monday and Basecamp offer customizable UIs. Gira is really strong for Agile methodologies. Detailed sprint tracking, reporting essential for managing the rapid development cycles inherent in MEV strategies.
And CI/CD. Continuous integration, continuous delivery. What does that look like?
For CI/CD, Jenkins is a powerful open source option for automating builds, tests, deployments. But in the flash loan context, these pipelines need to be exceptionally secure and efficient. Frequent commits, keeping builds green, streamlined automated tests running against those local blockchain forks we mentioned, and rigorously securing deployment pipelines to prevent malicious code injection. A deployment error here isn't just an inconvenience, it can be catastrophic. Tools like Red Hat OpenShift GitOps and Ansible Automation Platform offer advanced Git-driven workflows for automating environments, which is critical.
AI coding assistants, like GitHub Copilot. Useful here.
Increasingly so. GitHub Copilot can provide intelligent suggestions, speed up coding, help adhere to best practices by learning from tons of code. It can help draft boilerplate, suggest gas optimization patterns, even highlight potential vulnerabilities based on its training. Human oversight is always required, though. Don't trust it blindly.
And finally, interacting with external DXs and platforms. APIs are key.
Yes. Postman is great for designing, testing, documenting APIs. Crucial for integrating with DXs, lending platforms. Your bot needs to fetch real-time price data, liquidity info, submit transactions, all relying on well-tested API interactions. This whole toolkit, used precisely, forms the foundation for serious flash loan development.
All right, let's talk about the automation engine that makes flash loans truly hum. Crypto arbitrage bots. The definition of arbitrage is simple enough, right? Exploit price differences, buy low, sell high.
Simple concept, yeah.
But in DeFi, this isn't leisurely. It has to happen almost instantly because markets converge so fast.
Precisely. Automation is everything for speed. Arbitrage bots automate the entire process, letting users react far faster than any human possibly could, and it eliminates emotional bias, too.
Speed and liquidity, those are the keys.
Paramount. Speed of execution and available market liquidity. A human just cannot compete with the sub-second reactions of a well-coded bot watching the mempool 24/7.
And this is where flash loans truly shine, providing the capital.
Exactly. They provide the necessary capital, often massive sums, to execute these arbitrage opportunities, turning tiny, fleeting price differences into substantial profits without the arbitrager needing significant personal capital upfront. It's leveraging OPM other people's money, but with that atomic guarantee protecting the lender.
Which brings us neatly to maximal extractable value, or MEV, and the whole Flashbots ecosystem. What is MEV, fundamentally?
Okay, MEV, maximal extractable value. It's the profit that certain market participants think miners, or now staking validators post-merge, plus searchers and builders can extract by deciding how to include, exclude, or reorder transactions within a block they're creating.
And it's a big deal.
It's a systemic issue, especially on smart contract blockchains like Ethereum. Some argue it poses an existential risk if left unchecked.
Existential.
Because if every interaction on the blockchain becomes a battleground for MEV extraction, the network's efficiency just plummets. Gas fees for regular users skyrocket. Predictable manipulation erodes trust. It threatens the very utility of the decentralized system, potentially turning it into a playground, mainly for sophisticated bots, not an open financial layer for everyone.
That's quite a stark warning. What are some of the main MEV strategies these bots are using?
Well, the most common is still arbitrage, as we discussed. Bots watch the mempool, spot price discrepancies, submit their own transaction with higher gas fees to front-run or back-run existing trades. Classic MEV.
Okay.
Then there's liquidation. Searchers exploit decentralized lending apps where collateral dips below the minimum requirement. They swoop in, trigger the liquidation, buy the discounted collateral, and immediately resell it for profit. All atomic, often using a flash loan to initiate the liquidation.
I've also heard of sandwich attacks, which sound pretty unpleasant.
They are highly unpleasant for the victim. MEV extractors essentially sandwich a user's large pending trade. They place a buy order just before the user's trade hits, then place a sell order just after it executes.
Profiting from the price impact they cause.
Exactly. They profit from the price movement caused by the user's own trade. This is value extractive. MEV, it directly harms the user, forcing them to trade at a worse price.
Are there even more complex versions?
Oh, yes. Things like poison sandwiching exist. This is where one MEV bot targets another MEV bot, submitting a cleverly designed, seemingly profitable, but ultimately flawed transaction bundle meant to trap or waste the competitor bot's gas. Then there are just-in-time, or JIT liquidity attacks. These leverage unique DX features, like Uniswap v3's concentrated liquidity ranges. A bot provides liquidity only for the instant a large trade occurs within a specific price range, captures the trading fees, and then immediately removes the liquidity, extracting value as a fleeting LP.
Wow. Okay, so Flashbots stepped in to try and mitigate some of this, especially front-running.
Right. Flashbots is primarily a research and development org focused on limiting the negative aspects of MEV, particularly front-running. Their main tool is a private transaction pool.
Private meaning?
Meaning it's accessible only by specific roles, searchers, relays, and validators. It bypasses the public mempool where typical front-running happens, creating a more, let's say, orderly market for MEV extraction.
Searchers are the ones hunting for opportunities.
Exactly. Searchers are typically non-validators who identify MEV opportunities and build bundles. These are atomic, immutable sequences of transactions. These bundles include a fee, a tip for the validator who includes it. The searcher keeps the MEV profit from their own transactions within the bundle.
And relays.
Relays act as trusted intermediaries. They're data availability layers, communication interfaces. They aggregate proposed blocks, containing bundles, from various builders and submit the highest paying valid block to the validators. They handle things like block escrow, data availability checks, validator registrations. MEVBoost is software that acts as a sort of relay aggregator for validators, letting them connect to multiple relays.
It sounds like it formalizes the MEV game.
It does, in a way. It makes MEV extraction more transparent and arguably less damaging to regular users by taking the most predatory front-running out of the public mempool. Validators have a clear economic incentive to participate.
Which explains why Flashbots adoption grew so rapidly. Went live Jan 2021, peaked over 60% of Ethereum blocks by July 2021. That's fast uptake.
The economic incentives are powerful, and the data shows that something like 90.5% of Flashbots bundles are submitted either to extract MEV, arbitrage, liquidation sandwiches, or specifically to protect against MEV extractors. It's a sophisticated economic game played out in milliseconds.
Let's get down to brass tacks then. How do you actually construct and deploy these arbitrage or Flashbots? What's the automation workflow look like?
Typically, it starts with continuous mempool monitoring. Bots are constantly scanning for those pending transactions, large swaps, DX interactions, liquidations brewing.
Then analysis.
Then algorithms kick in. They analyze the current blockchain state, compare prices across multiple exchanges or liquidity pools. If a potentially profitable opportunity is found meeting certain criteria for size, gas costs, potential profit, the bot crafts that bundle of transactions.
The bundle being.
The flash loan request, the sequence of arbitrage trades across different protocols, maybe interacting with multiple DXs, and critically, the final repayment of the loan plus the fee. Then submission. The bundle is submitted to the network, possibly via flashbots for that MEV protection, hoping to get included in the next block ahead of competitors.
Sounds like it requires some serious technical depth. What are the core development requirements?
Deep technical expertise, no question. Solidity for the smart contracts. A very thorough understanding of blockchain mechanics, gas auctions, block construction, state changes, and a strategic, almost algorithmic approach to finance.
Integration work.
Yes, integrating with DXs and lending platforms like Aave, Uniswap, DYDX via their APIs. You need that to fetch real-time data prices, liquidity, and to actually execute the trades programmatically. And you absolutely must develop sophisticated risk management algorithms.
Calculating profit loss, stop losses.
Exactly. Calculating potential profit after estimated gas costs. Implementing stop-loss mechanisms if market conditions shift violently mid-transaction. Managing liquidity risk, ensuring your massive flash loan trade doesn't cause so much slippage it eats all your profit.
And testing is paramount. You mentioned the hard hat fork.
Absolutely non-negotiable. Setting up a testnet environment like a hard hat fork to simulate trades without risking real capital is crucial. Allows rigorous debugging, optimizing bot performance, testing edge cases, and security measures are vital.
Like audits and key management.
Code audits by reputable firms. Secure storage for private keys. Never embed secret keys in your code. Use secure key stores, hardware wallet integration, or encrypted environment variables. Extensive vulnerability testing for reentrancy, integer overflows, access control issues. A single bug can wipe you out or get you exploited.
For people looking to get started, are there open source options they can study, or is it mostly commercial platforms now?
There are definitely open source options. Lots of GitHub repositories exist for Solidity Node.js flash loan arbitrage bots. They can be fantastic learning resources. You can study the code, adapt it, but they often require significant development work to be truly production ready. They might not be optimized for the latest market dynamics, gas efficiencies, or MEV protection techniques. On the commercial side, you've got platforms like 3 Commas. They offer user-friendly interfaces, automated bots, smart tools, analytics for various strategies.
Easier entry point.
Potentially, yes. Pionex is another interesting one. Pioneered offering free built-in trading bots. Good for newcomers, gives market insights, access to liquidity across exchanges.
And for more advanced monitoring.
Arbitrage Scanner offers different pricing tiers from like $69 for a basic test plan up to nearly $2,000 for an expert plan. They focus on monitoring assets across both centralized CEXs and decentralized exchanges, DEXs, including advanced cross-chain arbitrage spanning. Gives you that edge in spotting opportunities.
What about coding your own bot, but with some help?
Trality is interesting there. It provides a browser-based Python bot code editor for coders, but it also has a drag-and-drop interface for users without coding skills, plus back-testing and live deployment capabilities. So these tools really represent a spectrum from pure DIY coding to fully managed automation platforms. Each needs a different level of technical engagement and cost.
So we've covered the building blocks, the automation. Now let's trace the full life cycle of these flash bots. From initial concept to deployment, monitoring, and hopefully profit. It starts with system design, right? Defining the architecture.
Yes, system design and functionality first. Defining how the automated trading system will actually function. Thinking about architectural patterns, maybe a dynamic broker pattern for load balancing if you're hitting multiple endpoints, or an advanced repository pattern for abstracting data sources cleanly.
Laying the groundwork.
Exactly. How will components interact? How will it scale under high stress, like peak volatility? Then comes source code management and implementation. Using version control like Git rigorously, implementing robust, clean code, embedding those risk controls we talked about directly into the logic, making sure it's functional, secure, auditable, manageable for updates. You have to consider failure modes, what happens if gas spikes, if a DX call reverts unexpectedly.
And testing, a multi-layered approach.
Absolutely thorough testing protocol. First, unit testing, focusing on discrete units of code individual functions, testing both positive scenarios, valid inputs, and negative ones, invalid inputs, edge cases. Clear naming conventions for tests are vital here, especially with complex logic.
Beyond unit tests?
Functional testing, confirming the entire system behaves as specified. And just as importantly, confirming it doesn't behave in unintended ways that could lead to exploits or losses. Then, scalability testing, ensuring performance holds up as you scale, maybe monitoring more pairs or exchanges. And finally, exchange-based conformance testing, verifying your bot interacts correctly with the specific quirks and rules of each DAX or protocol API. Maintain orderly markets, avoid errors.
Okay, testing complete. Deployment time.
Right, deployment to production. And the key here is promoting the exact same tested build artifact through successive environments, from your local machine to testnet, finally to mainnet. Ensures consistency, avoids introducing new bugs during deployment.
And integrating MEV protection is a key step here.
Crucial stage for it, yes. Implementing techniques like transaction privacy if possible, maybe using ZK proof so that's advanced. Integrating with Flashbot's private pools for submission, that's the standard way to reduce front-running risk.
Other strategies.
Randomized order submission can help throw off predictive bots. Setting appropriate slippage tolerance is vital to avoid bad fills due to front-running or sudden volatility.
Multi-DIX integration needs careful handling too.
Yes, employing advanced algorithms and smart contracts for seamless integration across multiple DEXs to optimize strategies, find the best routes, and of course, fail-safe mechanisms and robust error handling are absolutely critical. Protect against unexpected errors, potential losses.
Like circuit breakers.
Exactly. Implementing circuit breakers to automatically halt operations during suspicious activity or extreme market swings. Time locks on critical administrative functions to prevent immediate, potentially disastrous changes. For instance, a circuit breaker could halt all bot activity if gas fees suddenly spike 10x, saving you from racking up huge losses on unprofitable transactions.
The life cycle doesn't stop at deployment, though.
Not at all. Continuous monitoring and alerts are essential. Real-time monitoring of operations, bot performance, market conditions using those analytics platforms and custom alert systems. And finally, documentation and change management. Maintaining clear docs for system design, access controls, operational procedures. Implementing strict change management for pipeline configurations. Ensures long-term sustainability, adaptability.
Okay, let's talk about the money. The economics of flash loans. What kind of investment do you really need? We know they're uncollateralized, but...
Right, the loan principal itself doesn't require your collateral. That's the magic. But, and it's a big but, you absolutely do need enough capital, usually in the chain's native token like ETH, to cover the gas fees.
And those can be significant.
Especially for complex multi-step transactions. Even if your entire flash loan operation fails and reverts, you still pay for the gas consumed. That's your primary upfront financial risk. It could be hundreds, even thousands of dollars for a single complex failed attempt.
Beyond gas, there's the cost of the bot itself.
Definitely. Bot development cost. This ranges hugely. It could be your own time investment if you're skilled in adapting open source code, or it could be a significant financial investment for commercial bots or hiring custom developers. Those commercial arbitrage scanners we mentioned, hundreds or thousands a month. That's real outlay before you even make a dime in profit.
So how do the flash loan providers make money if the loans are risk-free for them due to atomicity?
Mostly through those tiny fees on the loans, that 0.003% fee on the borrowed amount. Sounds minuscule, right?
Yeah.
But aggregate that across billions, maybe trillions of dollars in loan volume over the technology's lifetime. Providers have reportedly generated over $90 million in revenue just from these tiny fees.
Wow. Because their cost is basically zero.
Exactly. The marginal cost for a protocol like Moova to offer flash loan functionality once the contracts are deployed and audited is essentially zero, so those fees are almost pure profit for them. Some providers even use flash mints.
Flash mint.
Yeah. Instead of lending existing tokens from a pool, they momentarily mint brand new tokens for the duration of the loan and then immediately burn them upon repayment. This allows for virtually unlimited liquidity without impacting the overall token supply. Their incentive might be less about direct fees and more about increasing the utility and adoption of their protocol and its native token.
So with all this accessible capital, what are the legitimate ways people are actually profiting from flash loans? Arbitrage is the big one.
Arbitrage trading is the primary, most common, and most legitimate use case. Traders capitalize on those fleeting price differences between DXs. Borrow huge sums via flash loan, buy low on DXA, instantly sell high on DXB, repay the loan, pocket the difference minus fees and gas.
And the volumes are huge.
Reportedly, Ethereum arbitrageurs executed over $400 million worth of flash loan-based trades in 2023 alone. That's a staggering figure reflecting the scale.
What else besides arbitrage?
Liquidations are another key strategy. Identifying those under-collateralized loans on lending platforms, using a flash loan to repay the debt and claim the discounted collateral, then immediately selling that collateral for a profit. Collateral swaps are also common.
How does that work?
You use a flash loan to pay off an existing loan, freeing up your original collateral. Then, within the same transaction, you immediately take out a new loan using a different asset as collateral. People do this to optimize interest rates, manage risk exposure, or just unlock capital from a position without actually closing it fully.
And simplifying leverage.
Yes, creating or transferring leveraged positions. Flash loans can dramatically simplify the steps needed to open or move leveraged positions across different DeFi protocols much more efficiently than doing it manually with your own capital step by step. It's a powerful tool for capital efficiency.
Okay, let's distill this into concrete steps for success. Learning, deploying, monitoring, profiting. It's a journey. What's the learning phase look like?
Step 1. Solidify your blockchain and DeFi fundamentals. Master atomicity, smart contracts, how common protocols like AMMs and lending platforms actually work under the hood.
Thank code.
Then, intensive Solidity and Web3.js or Ethers.js training. Learn to write, test, and securely interact with smart contracts. You also need to study market dynamics, liquidity pools, AMMs, how price discrepancies arise, and why they persist, even for milliseconds. Then, deep dive into official protocol documentation. Read the white papers, the developer docs for Aave, Uniswap, DYDX, whoever you plan to interact with. And critically, utilize testnets and hard at forks constantly. Practice bot development, strategy execution, gas optimization in a risk-free environment. Iterate, iterate, iterate.
Hey, ready for the deployment phase.
Develop and rigorously audit your smart contracts. Make them efficient and secure. Engage third-party auditors with DeFi experience. Use static analysis tools like Mythex or Slither. Implement those robust risk controls we discussed, P&L calculation, stop losses, dynamic slippage tolerance baked into the contract logic.
Integrate and protect.
Integrate with DeFi protocols using their official APIs. Connect your bot to target exchanges, lending platforms. Prioritize MEV protection. Seriously consider flash bots for private transaction submission. Implement other anti-front-running techniques. And secure your infrastructure. Use secure key stores, apply principle of least privilege for contract permissions, implement solid CI/CD security practices.
Now the ongoing monitoring phase.
Real-time mempool and on-chain monitoring. Use advanced analytics platforms like Nansen, Dune Analytics, or build custom scripts to detect opportunities and track your bot's live performance. Set up comprehensive alert systems, get notified immediately of unusual activity, big market shifts, potential attacks, or even just consistently failing transactions, and continuously track gas costs and profitability. Analyze transaction costs against realized profits to constantly optimize your strategies. Are you actually making money after gas?
Finally, the profiting phase.
Yeah.
Assuming all goes well.
Identify high liquidity markets. Focus on currency pairs and DXs with enough depth to handle your large trades without causing excessive slippage that eats your profits. Optimize your arbitrage algorithms. Relentlessly speed and efficiency are everything to outcompete other bots, often by milliseconds. Explore novel MEV strategies beyond simple 2-day-X arbitrage. Look into liquidations, JIT liquidity, more complex multi-step opportunities. And always stay updated on protocol changes. Flash loan providers release updates, patches, security alerts on official channels. This is not a set-it-and-forget-it game. It's dynamic, constant adaptation.
This powerful technology, as you expect, comes with significant potential risks. Flash loans have a, let's say, controversial reputation, partly because they can be used to fund various economic attacks and exploits. This is the dark side, isn't it?
It is, unfortunately. One major risk is price manipulation. Flash loans provide the capital needed to execute attacks that manipulate asset prices on DXs or exploit weaknesses in price oracles.
Like that pump attack example.
Exactly. Where 10,000 ETH was borrowed via flash loan to deliberately manipulate ETH WBTC prices on Uniswap and Compound, creating artificial arbitrage opportunities that benefited the attacker at the expense of the protocols or LPs. These aren't theoretical, they're sophisticated, coordinated exploits.
And vulnerabilities within the protocols themselves.
Yes, attackers constantly probe for flaws in smart contract logic. Things like reentrancy attacks, integer overflows or underflows, or even subtle design flaws that weren't caught in audits. We saw this with the Hedgie Finance attack. A vulnerability in their Create Locked campaign function let an attacker get a refund while keeping the approval to spend the funds, leading to a $2 million loss.
The total losses are huge.
Staggering. Flash loan attacks have led to losses totaling well over $100 million across various incidents. FlashGuard, that monitoring service, estimated potential losses of up to $405.71 million in historical attacks they analyzed. These aren't mining bugs, they're often fundamental architectural oversights exploited at scale.
Beyond outright attacks, there's that ever-present threat of MEV and front-running again. The space is hyper-competitive.
Incredibly so. Often described as survival of the smartest against hundreds of people better than you, and highly optimized bots. This competition manifests as front-running.
Your profitable transaction gets sniped.
Exactly. Detected in the public mempool, copied by an MEV extractor who pays higher gas to get their identical transaction executed just before yours, stealing your profit. It's a systemic consensus layer vulnerability, as some call it. And sandwich attacks, as we discussed, directly harm users by manipulating prices around their trades. It's a constant digital arms race.
It sounds genuinely cutthroat. And even if your intentions are pure, your own code can be the vulnerability, right?
Absolutely critical point. Even well-intentioned bots can have flaws. Bugs in your own smart contract logic, maybe a subtle reentrancy vector you missed, an integer overflow on an edge case calculation, an unhandled exception can lead to unexpected losses or make your bot vulnerable to exploitation by others. A small logical error can open the door.
Then there are the more general technical risks of just operating on a blockchain.
Right. Network congestion and latency are huge concerns. Delays or sudden gas spikes can cause your carefully timed trades to execute at unfavorable prices, or just fail entirely, instantly wiping out expected profits. Speed and minimal latency are absolutely critical.
Milliseconds matter.
Definitely. System failures or bugs in your bot's off-chain infrastructure, maybe a misconfigured API connection, a database issue can lead to unintended trades or missed opportunities. And as we keep saying, even if your Flash loan transaction fails for any reason, you still pay the gas. Direct financial loss, no game.
Liquidity risk sounds like another easily overlooked one.
It is. Insufficient liquidity in your target markets or pairs can completely derail a strategy. You might borrow $10 million via Flash loan, but if there's only $1 million of liquidity available on the target DX at your desired price, your trade won't execute properly, or you'll suffer massive slippage, making the whole thing unprofitable. And we can't ignore regulatory risk.
Still the Wild West in some ways.
The DeFi space is constantly evolving. Changes in local or international regulations could significantly impact trading strategies, the legality of certain operations, even the viability of protocols. Adds another layer of uncertainty.
Finally, there are some pretty serious ethical concerns, and this issue of wash trading.
Yes, the ethical line can be blurry. Is arbitrage purely efficiency enhancing, or does the sheer volume of bot activity unfairly drive up gas costs for regular users? It's debated. And Flash loans definitely enable wash trading users simultaneously buying and selling assets without changing their net position, just to artificially inflate transaction volumes and perhaps mislead investors about a token's activity.
Banned in TradFi, but possible in DeFi.
Enabled by DeFi's permissionless nature. Some critics genuinely argue that Flash loans, due to their use in exploits and manipulation, cause way more harm than they could ever make up for. It's a strong critique questioning their net benefit to the ecosystem.
That's a powerful statement about the ambiguity. So given all these pervasive, serious risks, what robust safeguards can people actually put in place?
Okay, safeguards. First and foremost, smart contract audits and vulnerability testing. Non-negotiable. Engage reputable third-party auditing firms. Look for names like QuantStamp, Trail of Bits, consensus diligence firms with proven DeFi security track records. Have them review your contracts thoroughly.
Complement with tools.
Yes. Use automated static analysis tools like MythX, Slither, Securify. They complement manual audits, catch common issues. Consider bug bounty programs, maybe via platforms like HackerOne or Immunefi, to incentivize ethical hackers to find vulnerabilities before malicious ones do. And critically, stay vigilant. Regularly update and patch your smart contracts to address newly discovered vulnerabilities. The threat landscape changes constantly.
For Flash loan attack prevention within your bot's operation, beyond just secure code.
Monitor the mempool constantly for unusual activity patterns, sudden volume spikes, large, suspicious transactions targeting protocols you interact with. Implement time locks on critical administrative functions in your contracts to prevent immediate, potentially harmful changes. Use circuit breakers in your off-chain logic to halt operations automatically during suspicious activity or extreme market volatility. Protect your capital.
Control the blast radius.
Exactly. Consider transaction controls. Maybe limit the amount of collateral that can be borrowed in a single transaction via your contract, reducing the potential impact if something goes wrong. Use multi-signature wallets for deploying contracts or controlling administrative functions, adding layers of approval. And consistently educate your team, if you have one, on the latest security threats and DeFi best practices.
Beyond flashbots, any other MEV protection strategies?
Transaction privacy techniques are emerging, like using zero-knowledge proofs, though they add complexity. Randomized order submission, as we mentioned, can help obscure your strategy. Setting appropriate, perhaps dynamic, slippage tolerance protects against bad fills due to front-running or volatility. And when interacting with other DeFi protocols, prioritize those with a long, proven operational history and demand access to their audit reports. Build on secure foundations.
It sounds like a crawl, walk, run approach is really wise here.
Yeah.
Don't dive in head first.
Absolutely. Always start small. Test new strategies, new code deployments with minimal capital first. Limit your downside if unforeseen issues occur, network congestion causing failures, a subtle bug you missed, and stay informed. Continuously track announcements from the major flash loan providers and protocols you use. Security updates, patches, community alerts often come via official blogs, Discord, Twitter.
Fail-safes are key.
Robust fail-safe mechanisms and comprehensive error handling in both your smart contracts and off-chain code are critical. Protect against unexpected errors, enhance the reliability of your system, maintain trust if others interact with it. Your bot needs to be resilient to the inevitable chaos of DeFi. #tag
Wow. What a journey we've taken today.
Wow.
We've really gone deep into the sophisticated world of flash loans, haven't we? From their foundational atomicity right through to the cutting-edge bots, hunting for profit and market inefficiencies. We've explored the essential developer tools, the complex techniques, the significant financial opportunities, and equally, the very significant risks that define this advanced corner of DeFi.
It really underscores the need for deep technical understanding, constant vigilance, and frankly, a healthy dose of paranoia. The speed, the scale, the complexity, it demands a level of expertise and strategic thinking far beyond what most people encounter in traditional finance. And that dynamic interplay between arbitrageurs, MEV searchers, protocol developers, it's constantly reshaping the landscape. It creates this incredibly fast-paced environment where only the most adaptable, the most secure can really thrive long-term.
It's a testament to the innovation blockchain enables, but also a stark reminder of the vigilance required. So here's a final thought for you to chew on as we wrap up. The very nature of flash loans, leveraging these atomic transactions, it really does hint at a future where similar risk-free, uncollateralized lending could potentially exist in traditional financial markets, especially as they undergo more digitization and tokenization.
Interesting thought. TradFi flash loans.
Maybe. What might that mean for capital efficiency globally? For market liquidity? For systemic risk? Imagine a world where any asset, tokenized stocks, bonds, real estate, whatever, could be instantly borrowed and repaid within an irreducible sequence of operations.
Could lead to unprecedented financial fluidity or introduce entirely new systemic vulnerabilities we haven't even conceived of yet.
Exactly. The principles behind Flash Loan, born in DeFi, might just be a glimpse into the future of global finance, challenging us all to consider the profound implications of such power in a fully digitized, interconnected world. Something to think about.